Dagster is a declarative, asset-based orchestrator that redefines the way we think about managing complex workflows. A lot of you are familiar with Apache Airflow, which is the first orchestrator to gain immense popularity. Airflow focuses on imperative scheduling, which are sequences of tasks that execute in the right order. Declarative scheduling, on the other hand, is when you tell Dagster, hey, here are my data dependencies, but you don't explicitly define the order. Dagster will figure out the complexities for you so you can focus on other things that matter. Instead of thinking in terms of task, we try to think in terms of data assets. Let's say we're baking cookies, right? And we have a bunch of ingredients, we mix it together with a bowl and spoon, and we make some cookie dough. We take some chocolate chips and our cookie dough, we mix it together, we get some chocolate chip cookie dough, we put it in the oven, and after 30 minutes, we get chocolate chip cookies. Obviously, we're not trying to bake cookies here, but an asset could be something like a database, a file, or a machine learning model. In one of my previous videos, I mentioned how Airflow is the gold standard in the industry, but Airflow also has many pain points. And companies such as Dagster, Prefect, Mage, they aim to solve these pain points. This video is a full course that will hopefully help you get started. For those of you that have been waiting, thank you so much for the wait. I've been really busy these past couple of months with work, travel, and other things. I haven't forgotten about the channel yet, but I also didn't want to post videos unless I felt like it would truly benefit you. There's so much content in this video, and I hope you will learn loads. I did tons of planning, and I'm really excited about this video. So anyways, enjoy, and let's dive right in. Let's learn Dagster through creating a project from scratch. I want to start off with system design first and walk you through the high-level concepts to understand. This GitHub link repo will be in the description below, and by the end of the tutorial, hopefully you'll be able to recreate this project yourself. So here are the 5 learning objectives. So I want to focus on learning how to create assets, and we'll do that using Python decorators and focus more on the thought process behind how to design these Dagster projects. And the second thing I want to cover is how to use embedded ELT using data load tool. So data load tool is a third-party library, and it turns out that Dagster has this really great ability to understand third-party libraries. We'll learn about how to backfill DAGs using partitions, and DAG stands for directed acyclic graphs. Partitions could be something like a daily partition or a weekly partition, and they're really helpful when we're trying to chunk data when the size of your data is too big. Partitions are also really helpful when we want to make our DAGs faster and more reproducible. The fourth thing I want to cover is how to set up schedules and jobs. So a job is basically a group of assets, and a schedule is you can think of it as a cron job. And the last thing I want to cover in this project is how to build sensors and set your auto-materialization policy. So sensors and auto-materialization are pretty advanced-ish topics, and sensors are an event-driven way of triggering DAGs, essentially. Auto-materialization allows Dagster to create declarative scheduling, so you don't need to worry so much about how to set the schedules. This is how the GitHub repo looks like. You can see how to install the project. And let's take a look at system architecture now. So as a data engineer, it's a pretty common pattern to go from some kind of transactional data source over here on the left-hand side to an analytical database, so Snowflake on the right-hand side. So your transactional database, or OLTP, could be something like Postgres, MongoDB. They're typically very write-heavy database, and they can come from your APIs, your customers. Another common pattern for transactional databases is data is typically sharded. So when you shard data, it means that you're storing data across multiple machines by splitting it into smaller chunks. And we'll use the MongoDB Atlas cloud offering, which automatically shards data for the data set we're using. By the way, we're choosing this mfix dataset for our project. So this sample mfix dataset is a database about movies and movie theaters. The collections, we can see comments, embedded movies. MongoDB is a key value store, so we can see the the structure of our documents in each of these collections. So let's go back here. So how do we transfer data from transactional to analytical? It turns out that there are many tools in the industry that help us with that. Over here, we chose data load tool to essentially put our data in a data warehouse. A data warehouse is basically an abstraction layer over a bunch of columnar data formats, and it is our source of truth. A data warehouse is typically a read-heavy database, and we write it in batches only. Below everything sits Dagster. So Dagster sits between everything as the data orchestrator. Dagster doesn't actually run these steps, but it tells these steps when to run in what order. So using Snowflake, we'll create 4 different assets to basically try and answer some business questions about this data set. What is the user engagement? What are the top movies per month by engagement? And we'll create movie embeddings. And we have a data lake here that stores the final results of these 3 assets for user engagement movies. And with this data lake, we can serve it to our users. Our users could typically come from some kind of management background or could be a business analyst. And for movie embeddings, I'll show you how to create this using sensors, and basically we can use scikit-learn or some kind of machine learning framework to generate insights. Now let's set up our source database in MongoDB. Click on this mflix dataset, go here, and then let's click on load sample dataset. So I'm going to sign in my MongoDB account very quickly. So once you're in MongoDB Atlas, which is the cloud offering of MongoDB, hit create new project. Let's call it Dagster MongoDB. And click next. Hit create project. Hit create a cluster and click on free. Let's call it my cluster. And hit create deployment. Yeah, once you create a cluster, remember your username and password. Copy paste this somewhere safe. Copy paste it. Create a database user. Then choose a connection method. We'll click on drivers. And then remember this piece of the code here. So this is basically your connection string to MongoDB. Now click load sample data. And this will automatically load the mflix dataset for you. It might take around 15 minutes to run, so just be patient. So while this is running, go to your Snowflake account here. And then now let's create our warehouses, our databases, and the role. So I'm just going to copy paste some code in Snowflake and put it here. So use role account admin. I'm not going to talk too much about this, but basically creates a Snowflake warehouse for Dagster, a Snowflake database, a role, and then we grant the relevant permissions to these roles, warehouses, and database. Yep. Okay, let's take a look at MongoDB, see if our cluster is ready. Okay, it looks like it's done. Sample dataset is successfully loaded. So let's browse this collection. So now that we have MongoDB and Snowflake set up, let's create our Dagster project. So open a terminal. So just open my terminal really quick. And let's copy paste this to create a virtual environment and pip install Dagster. So copy paste this, paste it here. Okay, once that's set up, to create a new Dagster project, hit Dagster project scaffold -- name, and then name your project. So let's call it Dagster tutorial, or let's call it Dagster mflix. and cd into Dagster mflix. And let's open VS Code. So let's look at the file directory first. I'll give you a quick tour of Dagster. So over on the left-hand side, you can see this main Dagster folder and our test folder. So this main Dagster folder is basically where we define our assets, our jobs, our partitions, our resources, our schedules. And over here, you can see this main definitions function, which is your entry point to Dagster. So this init file contains your definitions function and is your main entry point. And this folder, Dagster test, is where you write unit tests for your assets. And these unit tests are typically written using PyTest. Now this guy here, setup.py, let's talk about this. And you can basically specify your install requirements here. So I'm just gonna copy paste some code here. So this is how I tell Dagster what libraries I require for my project. I can specify the library and the versions. And to run these installations, so let's conda activate Dagster mflix. So to install these requirements, just hit pip install -e .dev. This -e flag just stands for editable. So it just means that you can dynamically update your libraries. But let's keep it -e. And then dev stands for the target. So let's enter. Now let's go back to our diagram here. Now let's try and create this step here, this data load to ingestion step. So looking at the data load tool documentation, so we basically need to create a pipeline to sync data from MongoDB to Snowflake. So click on integrations in DLT. We can see a bunch of different sources from Airtable, from MongoDB. And similarly, we can see a bunch of different integrations from here to like DuckDB, ClickHouse, Postgres, Snowflake, Athena, Redshift, Databricks. So I'm just going to stick with this one. Going back to VS Code here, I'm going to create a directory called DLT. And I'll cd into DLT and run pip install DLT Snowflake. Yep, it's already installed. Then run DLT init MongoDB, which is a source, and then Snowflake, which is a destination. Hit yes. Yep, and then just quickly run this pip install requirements. Pip install requirements to install all these packages for Apache Arrow and PyMongo. So now that we have set up DLT, so in this folder here, I'm gonna copy paste or cut this MongoDB folder into so we're just gonna copy paste it. So we're just gonna cut and paste this MongoDB folder in this Dagster mflix. So I don't really need this DLT folder anymore. I just wanted to generate the code here. And now let's create an asset to run this MongoDB script. So create a folder, let's call it assets, and let's call this mongodb.py. So mongodb.py, import data load tool, and from this MongoDB folder that I just created, import MongoDB. This will allow us to set up the connection to MongoDB. And let's call our connection mflix MongoDB. I'll set my database. So let's call this one sample mflix. And then with resources, comments, and embedded movies. So I'm basically just picking two tables out of the sample data set here. So remember how we have comments and movies? I'll just pick these two. I'm just going to copy paste some code here to import some libraries for Dagster to get the asset execution context and the resources to connect to DLT. And over here, just going to copy paste some code again. Okay. So over here, this is how I would define assets. I would use some kind of Python decorator. In this case, DLT assets is a Python decorator that's maintained by the DLT community. And we set our source, which is this guy over here. And then we create our DLT pipeline. So we call our pipeline name local Mongo. Our destination is Snowflake, and our dataset name is Mflix. And this syntax here is a little bit awkward and ugly, but basically I pass in a context for Dagster, and I pass in a resource to this asset in order to run this DLT. Yeah, so this will make more sense in the future, down the line. So just bear with me at the moment. So now that we created our assets, what do you think we need to do next? We need to go to this definitions class to update our assets to include it. So I'm just going to delete this from assets, import MongoDB, and then from Dagster embedded ELT, .dlt import Dagster DLT resource. And I'm going to load all my assets from this module. So line number 6, load assets from modules, and let's call it MongoDB assets. And copy paste it. Let's do it here. Load our assets, and we'll define our resources. So let's call it DLT, copy paste it here. Let me quickly delete this assets.py. So run Dagster cd into the main directory, run Dagster dev to start the web UI. So launching Dagster services. There's an error. Let's look at this. So why do you think there's an error? It says config field missing exception. And the reason why we get this error is because we need to specify our environment variables. So let's quickly do that. So create .env file, and I'm just going to copy paste my environment variables here. Copy paste it. Whoops. And copy paste your credentials here. So in this case, I just created my MongoDB cluster. I put it here. And we need to define our environment variables for our Snowflake username, Snowflake account, Snowflake password. So the way you would do that is you would export Snowflake account. So I'm just going to quickly do this and blur out the section. Once you're done setting out your credentials, let's try Dagster dev again. And we can see our environment variables loading. And it's running successfully on port 3000. Let's click on this. And this is what our Dagster UI looks like. The two assets that we created for comments and embedded movies, you can see it right here. So I'll give you a very quick high-level tour, but let's go to overviews. You can see some tabs on jobs, schedules, sensors, automaterialization, resources, backfills. Click on assets, This is where we would define our assets in Dagster, and then you can click on deployment. What I like to do is I click on assets, I go to global asset lineage. That way I can see all the assets I'm building for my team. Click on this materialize all to ingest data from MongoDB to Snowflake. And let's give it a few minutes while I check my phone. Oh, that took a long time. So we can see MongoDB DLT has been completed. We can see these assets have been successfully materialized. So click on comments. Click on runs, view run. Click on full message. Materialize DLT using these values. It took about 5 minutes to complete this. Check the logs. Standard error. One more thing is to go to Snowflake, click refresh, and just verify that your data exists in Snowflake. So click on Dagster DB. We can see mflix and mflix staging. So it creates a staging environment for our tables, and then it loads it into the production schema here. So we can see comments. Let's preview the table. There's data about the ID, some names, some emails, and click on embedded movies, preview table. Just double check that your data exists first. So now let's go ahead and create the 4 different assets in Dagster. So let's go create user engagement, top movies per engagement, top movies per month, and movie embeddings. So go back to my VS Code here. I'm going to create a new file called movies under the assets folder, movies.py. And over here, I'm going to import a bunch of libraries first. So import Dagster Snowflake, import Snowflake resource. Just quickly import some libraries. Yeah, so just going to quickly import these libraries into my movies.python class. So the way you would define assets in Dagster is by writing functions. So let's define a function, let's call it user engagement. And then user engagement is, we need to figure out a way to connect it to Snowflake. And we can do this using the Snowflake resource. So let's pass in Snowflake resource. And this function returns nothing, returns none. Let's create this first. We can create a bunch of other assets. So define top movies by month. And then we'll pass in Snowflake again. Returns none. Same thing here. Let's call it movies by engagement. So let's create these 3 assets for now. And to define an asset, we just add this decorator syntax here, asset. So copy paste it here. Once we define our function signatures for user engagement, top movies by month, top movies by engagement, how do we define data dependencies between them? And the way we do it is we would pass in a parameter. So let's call it deps equals, and I need to connect this user engagement with the ingestion step that I just created here, DLT MongoDB comments and DLT MongoDB embedded movies. So just gonna come here, copy paste this, put it here, and then copy paste this one again. So that's how you define dependencies. For top movies by month, let's do the same thing again. copy paste just movies. For the last one, top movies by engagement, I'll connect this user engagement asset with this top movies by engagement. So depths equals user engagement. Okay. So I'm not going to write the functions yet, but just try to understand how we define assets and data dependencies in Dagster first. Go to your main definitions function, and your main definitions entry point is basically what tells Dagster your assets, your resources, how to update it, so forth. So let's add our new assets. So movies, import movies. Let's add from Dagster Snowflake, import Snowflake resource. And let's add our movies asset. Movies assets equals copy paste load assets from modules. I'll call it movies. And then let's call the group name. Group names are a good way to organize your assets. Let's call it movies. And add it here. One more thing we need to do is to basically set up your Snowflake resource. So Snowflake equals here. So I'll just copy paste some code here. And this Snowflake resource is basically going to fetch your environment variables, your data warehouse, your database, your schema, your role, which is what we specify in this .env file here. So let's import envvar. What is envvar? The difference between using envvar and os-envvar is here. So using envvar, the variable's values is retrieved at runtime, and it won't be visible in the UI. Whereas using the regular os.getEnv, Dagster loads it at statically. So go back to the code base, take this Snowflake resource, we'll plug it in here. Let's call it Snowflake. This Snowflake resource is basically linked to this function input here, Snowflake resource. Here and here is the same thing. Okay, let's test if Dagster is able to load our assets. So click reload definitions in Dagster, and voila, you can see user engagement, top movies by engagement, top movies by month. So these aren't doing anything yet, so let's go and write code and actually generate data. Let's go back to movies. So what I'm going to do is I will specify a query in Snowflake. So let's query select from comments, join embedded movies on comments.movieid equals movies.id. So this join statement here, I go back to my database. I'm basically joining this movies.id with comments movie ID. These are the foreign and primary keys. So foreign key here, primary key. And group by movies.title, movies.year. Let's order by number of comments descending. And over here, we can select the title, the year, and Let's count the number of comments. Oops. So with Snowflake.get connection as con, let's create a cursor for our connection. Con.cursor. And execute the query. And let's get back the results in the pandas data frame. So engagement df equals cursor.fetch pandas all. Then we can output engagement df to CSV. And let's create a folder here called data. It's called data. Data/movies engagement.csv. Index equals false. Okay, let's see if this will work. Hit save. Go back to our Dagster UI. Hit reload definitions. Click on user engagement. Materialize selected. Oops. Typo, invalid identifier. Let's fix that. Save again. Reload definitions. User engagement, materialize selected. And now it's working. Go back to our data folder. Obviously, you wouldn't want to create a folder called data in production. In the real world, this could be something like a S3 bucket or a data lake or a data lake house. But for this project, for this purpose, I think a folder is fine. Okay, now let's go ahead and finish up these other assets. Top movies by month. So let's write a query to get the top movies by month. So let's select from embedded movies, let's call it movies, join embedded movies. Let's get the genre table, genres, on movies.dlt ID equals genres.dlt parent ID, where release, so released equals 2015 0101 and released So for now, I'm querying movie datasets that fall within this date range, but later I'll show you how to replace these using partitions. But we'll just hard code this. We'll just hard code this for now. So just keep in mind, and select movies.title, movies.released, movies.imdb rating, movies.imdb votes, genres.value as genres. So this SQL query is going to fetch your movies by genres and limit it to a certain date range. Then I select the title, the reviews, the votes, the genres, when it was released. Similar to the code on top, just copy paste this. Copy paste. But let's call this one movies data frame. Movies data frame. And now let's find the top films per genre. So let's call it movies DF. Let's specify a window for now. 2015, 01, 01, and then movies DF. Like, let's write some very simple pandas code. Get movies, they're grouped by genres, IMDb rating, dot IDX max. And same thing here, I'll output a CSV file. So with top movies by month.csv. So I run my Snowflake connection, I get the output as a data frame. I use pandas to basically find the top films per genre, and I output it to my data folder here. So save this, go to assets, reload definitions. Let's run this one, top movies by month, materialize selected. Another error, Embedded movie genre doesn't exist. Oh, I think it's another typo. My bad. So it should be, let's go Snowflake. It's a typo. To copy paste this table, put it here. Okay, this should work. Reload definitions, top movies by month, materialize selected. Okay, it's working. Last one, for getting the top movies by engagement. This part of the tutorial, I'm just going to copy paste some code. This code basically reads the, just going to copy paste it, and this code basically reads this data folder, the movies engagement CSV file that we created, and then we generate the top 10 movies by sorting it by the values of number of comments. We get the first 10 values using hit. So that's what this code is doing. Don't worry too much about it. I'm basically reading this CSV file. I find the top 10 movies sorted by the values of the number of comments, and I create a chart using Matplotlib. Save. Go to View Global Assets. Okay, reload definitions. Click Materialize Selected. And success. So this looks good. If I go back to my data folder here, so this is the result, the top movies with engagement with the year released. So The Mummy has the highest engagement, X-Men, Liar Liar, what else? The Sherlock Holmes, The Mummy, these are pretty good movies, pretty classic movies. Maybe I'll go watch them later. One last thing about assets is you can add descriptions for each asset. So over here we can add like a doc string, and the doc string is able to Dagster can pick up the doc string and add a description for assets. So let's call it movie titles and the number of user engagement. Here, same thing, let's add a doc string for each of our assets. Let's call it top movie genres based on IMDb ratings. Creates a bar chart based on top 10 movies by engagement. Click on assets, reload definitions. Now we see the description here. Movie titles and number of user engagement. Now that we've created our assets, I want to take a step back and talk about Dagster resources. It's very critical that we try to keep our code dry or don't repeat yourself. And things such as databases, they're components that can be reused across our asset diagrams here. So our Snowflake resource was used across this DAG here and this one. So resources could be a Snowflake, Databricks, or BigQuery connection used to we use where data is ingested to. It could be an AWS S3 bucket where the API's response is stored. The idea of using a resource is we can plug it in different implementations in different environments, and we can share these configs across multiple assets or ops. So if you're a data engineer, you might work with different types of databases. Maybe one part of your organization is using DuckDB, and the other part is using Snowflake, and your ML team might be using Databricks. So this is where you would kind of organize how you would think about using resources. Yep, you can see a bunch of APIs for resources. Anyways, let's go back to our code. I want to refactor our main definitions function here. So let's organize our folder a bit. I don't think we need this DLT folder, so delete this. So I'll create a new folder and let's call it resources. In resources, let's create init.py. We'll basically copy paste over our resources code here. So copy paste, put it here. And from Dagster import and var. And copy paste this here. Copy paste this again. Put it here. DLT resource. Once we define our resources, let's import it into our main definitions class. So from resources, import Snowflake resource and DLT resource. Copy paste. Save. This is what your final definitions file should look like. Hit save. Click reload definitions. Let's see. Whoops, let's call it Snowflake resource. How do we run this over some kind of schedule? So remember how we talked about the first part, how to set up schedules and jobs? So let's go with Dagster schedules. This is the documentation for schedules. So schedules are a traditional way to support automation. So it's very common for data engineers to set up a schedule for some kind of daily job, a weekly job, or it could be a micro batch hourly job. Schedules define a fixed time interval to run your pipeline, and they consist of a few things. They consist of a cron expression, and it consists of a job. A job is a group of assets where we want to run a schedule on. Jobs basically allow finer, more granular control over which assets to run. First thing we need to do to create a schedule and a job is to go here. Let's create a folder called jobs. And let's create init.py. And let's do from Dagster import asset selection and define asset job. Let's create our movies job, define asset job, the name of our job, we call it movies job, and the selection. So We'll take asset selection. Yep. So this is the one I was looking for. So let's copy paste this, select all assets except for those in group marketing. So copy paste this. And let's get all the assets except MongoDB. Yep, this looks good. Save it. Now create a new folder for schedules. Let's call it schedules. Create an init file. Init from Dagster, import schedule definition. From .jobs, import movies job. Movies schedule. We'll pass in the job we created, movies job. We'll define our cron schedule. So to get the cron schedule, cron type guru, you can define your schedule. So let's say I want to get every single minute. Just copy paste this. Run every minute. Demo purposes. Click reload definitions. What else do you need to do to add schedules of jobs? Update our definitions function. From .jobs, import movies.job. From schedules, import movies schedule. Over here, just add jobs, movies job, and add schedules, movies schedules. Reload. What is wrong? Oh, whoops, typo. So this would be cron schedule. Save. Okay, definitions reloaded. Click on overview, click on schedules, movies job schedule, click running. And this should schedule a job every minute. Okay, so after a minute, it says there's one run that's requested. You can click on this run, and it just finished running. So it looks like our schedule is working. I'll just disable this for now. One more thing I wanted to mention is, with schedules, this is not quite declarative scheduling yet. So we're still doing like what you call imperative scheduling. We're telling Dagster, run this DAG exactly at this time. And in order to turn this into declarative scheduling, we need to add automaterialization. And I'll talk about that at the end of the video. Yeah, so that's how you create jobs and schedules. Let's go back here. Now let's talk about third point, which is how to backfill your DAGs using partitions. Let's Google the documentation for partitions. In Dagster, you can essentially chunk your data or partition your data, which is a collection of chunks. Each partition function looks like its own mini asset, but they all share a common materialization function and dependencies. So why partitioning? We want to chunk our data for cost efficiencies, for speed and parallel processing. And in reality, we tend to process data in batches, and it's very common to process them in terms of months, in terms of weeks. Backfilling is a process of running a partition that hasn't been updated yet, or it doesn't exist. So that's how we're going to do with partitioning and backfilling. There are two concepts that are very interrelated with each other. Okay, let's create our partitions now. Go back to our project folder, click new folder, let's create partitions, create init.py, And from Dagster, let's import monthly partitions definition, which is copy paste it over here. Set our start date and end date. Create a monthly partition. Start date equals start date. End date equals end date. Once you have this, we need to update our assets to take in these partitions. How do we do that? Click on Assets, go back to Movies, go back to this piece of code here that I want to partition this SQL statement by the dates. But first I need to import my monthly partition. So from partition, import monthly partition. And copy paste this monthly partition. Go here, add partitions definition, paste it. So this line 35 was added. Next, we need to get the key of each partition. So how do you do that? So let's get the key. Partition date equals, we need to pass in a context now. And context dot partition key. Using this partition date, add it into our SQL statement. So turn this into the F string, and let's call this, whoops, partition date. Same thing here. Replace this, let's call it partition date. So I'll say that again. We add this new context input. We get the partition key from context, and we modify our SQL queries to add the partition dates. Let's delete the old top movies. Let's delete this for now, the old CSV file. Delete this code. Last thing we need to do here is I'm going to copy paste some code here. Copy paste this. I'm trying to find the top movie ratings per genre split by partition dates. So that's what line 63 to line 69 is doing. And line 77, the first time I run my partition asset, it's going to create a new CSV file. But the second time it runs it, and so forth, it's going to handle race conditions. Just read the existing data set, check if a partition already exists. If it exists, concatenate the existing data set with the new one and sort by the partition date and save it again. So that's what line 72 to 75 is doing. It's just reading an existing data set. I get the chunk or the partition chunk that's relevant. I replace it or concatenate it together. I sort by the values and I save it, overwrite it. And I'll just delete my data files again to rerun everything. So go back to Dagster, hit reload definitions. And now if I try to run top movies by month, click materialize selected, it's going to give me a new user interface here to select the partition dates. Over here I can select a range of dates. So let's say I want to pick the first or the latest 7 partitions. Just highlight this and click launch backfill. And we can see there are 7 partitions that are materialized here. Click on this, click on the partitions, asset catalog, click on partitions. So the latest 7 partitions are run. Now the last part of the course is on sensors and automaterialization policies here. Automaterialization policy is what makes Dagster declarative. You don't have to programmatically set the schedule. You can just set these policies and it will sort of figure out for you. Let's talk about sensors first. Get a documentation for sensors. A sensor is defined as something that allows you to run based on an external state change. For example, you can run whenever a file appears in S3. You can launch a run whenever a job materializes a specific asset. So it can be very flexible and powerful based on how you design it. But I'll show you how to do the first one, which is to launch a run when a file appears in some kind of folder or S3 bucket. Here's the API for sensors. Go back to my Dagster folder. It's getting a bit messy. Let's clear the screen. Let's create a folder called sensors and create init.py. Using init.py, I'm going to import some libraries, run request, sensor result, sensor, and import a bunch of other libraries. Import OS, import JSON, from jobs, import ad hoc job, and define my sensor. Let's call it ad hoc sensor. Add a decorator class, sensor, and attach on. Yeah, let's just call it sensor for now. And let's copy paste some code. Just to save us some time, just gonna copy paste this. So this code is basically, I define a path such that if a file appears in this folder, ad hoc, so let's create this ad hoc folder, keep track of the states of your runs. And if a file exists in this path to requests, and it ends with a JSON file, run this code. So trigger a job with these configs. That's what it's doing. And just return some results. And I need to create a job for this. So let's add a job called ad hoc job. Go to my jobs folder. Let's add a new job. Let's call it ad hoc job equals define asset job. Name equals ad hoc job. Selection equals asset selection dot assets. And let's see. Let's create a movie embedding asset. Let's call it movie embedding. So save this. Looks good. And all we need to do is to create a new asset for the movie embeddings. So if I go back to my system architecture diagram here, we're basically done with the first three. So let's create the fourth one, movie embeddings. So in assets, I'm going to create a new file. Let's call it ad hoc.py. And this part from Dagster, I'll try to talk about the important concepts. So the concept I want to highlight is this config class here. Let's define a new config. And a config has a file name and has some inputs. In this case, let's use ratings as an input. Okay, I'm going to import a bunch of other libraries too. Import a bunch of other libraries and define my new asset. So I have a question for you. How do you define assets in Dagster? Define movie embeddings And I just pass in an asset here. Yep. So let's set my dependencies. Deps equals, copy paste this here. Copy paste it. And for our function signatures, put config ad hoc config and pass in a Snowflake resource too. Snowflake resource. So over here, let's write a SQL query. So over here, query. Let's select from embedded movies, join embedded movies. So I want to get this plot embeddings table. So go back to Snowflake, this plot embeddings data set. This is the data that I want. However, you see this value here, it's in long format. And I need a way to essentially transform it and squish it into some kind of array to represent the movie embeddings. So that's what we're going to do. So join with the embeddings. We'll get movies title and call array aggregate. So I take these values, I squish it per movie title. So let's do group by movies.title and embeddings.value as plot embeddings. On movies.plt id equals embeddings.plt parent id. Where movies.imdb rating less than equals, I'll pass in the config, which is the ratings. So this guy here, line 10, I'll pass it to line 24. This looks good. Whoops. Oops, I missed out on this one. So embeddings. Save you some time and copy paste more code. So get the data frame using this SQL statement. Get the values as a data frame. Do some data processing. Copy paste this utility function. Yeah. Unwrap the movie embeddings, fill any values of 0, and we'll train a machine learning model using the t-SNE algorithm. And after we train the model, we create a scatter plot. So what is t-SNE algorithm? So t-SNE is a unsupervised ML method, I believe. And it's a way to visualize high-dimensional data. So after we train the model, we just generate the scatter plots, and we save it here. Okay. Go back to your definitions here, and let's add our new sensors. So from sensors, import ad hoc sensor. Copy paste this again, but let's call it ad hoc sensor. Oh, ad hoc assets. Let's add ad hoc. Let me quickly do this. Add your sensors. So once this is done, go back to Dagster, go to global lineage, reload definitions. Ooh, it works. Okay, so now we see this new asset here. called ad hoc movie embeddings. Now, how do we trigger this asset? If I go back to this ad hoc folder, so what I'm going to do is, so let me just create this file called ratings.json. And this JSON file is going to have an input called ratings. So I want to get movies that are above the rating 8.5. So 8.5 is a pretty high number. Let's say I have pretty high standards for movies. Save this. And go back here, overview, click on sensors, ad hoc sensor. And this sensor is going to poll every 30 seconds if a file exists in the sensor that we created, or the folder. So let's click running. So let's see, 0 runs requested after 0 seconds. So what happens if we move this ratings.json into this folder? Let's move it there. And then let's take a look. So a job has been kicked off, a run was requested, and it succeeded. Let's go back here. And now we can see our output, which is the T-SNE visualizations. So this is pretty cool. So these movies have similar scores, and this is a pretty good result actually. I'm quite surprised. Lord of the Rings movies, you can see they're all clustered here. So that's super cool. The Dark Knight, Batman, a classic, it's clustered here. Star Wars. We can see a bunch of other movies here for Terminator. So these are pretty good movies and the scores are pretty good. Last thing I want to talk about is auto-materialization policies. So auto-materialization enables us to have declarative scheduling. It's still an experimental feature. Instead of defining, workflows in your assets, you just describe conditions how they should be materialized. So and the way you set it up is using this auto-materialize policy. The most common way to set up assets to be auto-materialized is this eagerly policy. Immediately after an upstream change occur, a run will be kicked off to incorporate those changes to give an asset. So I'll show you how to do this very basic one just to get a general idea. So I'm going to add a new import for auto-materialize policy. Copy paste this, go down, and let's get the auto-materialize policy. Let's set it to eager. That means whenever an upstream change happens, run this asset. So save this. Click on auto-materialize. Click on running. Go to assets, reload definitions. If I run this asset, this will automatically run. So click this, materialize selected, confirm. So once this is completed, okay, it's working. So after 30 seconds, the auto-materialization policy will say, hey, there was a change that happened upstream, why are there no changes yet? So one materialization requested here. Yep, and so this was run at 1:07 p.m., which is 1 minute after this. Although I didn't manually run this, the auto-materialization policy will declare that this data asset needs to be updated. So this is really cool. That's all I wanted to cover for this video. If you reach the end of this video, it was quite a long video and I did a lot of planning. I hope you learned lots of it. So let's wrap up and talk about the high-level key points. Huge congratulations to you. You just finished your first end-to-end Dagster project. To summarize what we talked about in this video, we looked at how to create assets in Dagster. We looked at declarative orchestration, and declarative orchestration is basically setting your auto-materialize policy, although I only briefly talked about this. At the start, we talked about how to use data load tool, which is a third-party library, and it turns out that Dagster has very nice features to understand third-party libraries. And that's one of the things I like about the software. We looked at how to construct partitions using DAGs and how to backfill these DAGs using partitions. We learned how to set up schedules, and schedules are a way to define a cron schedule. We looked at jobs. Jobs is a way to group different assets together so that you can trigger them. And last but not least, we covered some experimental features such as sensors. Try not to memorize any of the steps. I felt like the reason why when I was recording this, I purposely left all the mistakes I have, and I was kind of debugging it on the spot with you. And I was also Googling the documentation together with you. And that's kind of where the value lies, like the ability to debug, to look at the documentation, to have critical thinking. That's the key skill that I want to teach you. I hope you got a lot of value out of this video. If you enjoyed it, hit that like button, subscribe, and share the video. Anyways, I'll see you next time.